Okay, so let's look at 1, 1, 1, 2, and 1, 3. So an equation containing the derivatives of one or more unknown functions with respect to one or more independent variables is called a differential equation, DE. So a differential equation with only one independent variable is called a ordinary differential equation, or ODE. Otherwise, it is called a partial differential equation. So let's look at some examples now. Okay, so here are some examples of ordinary differential equations. So for ordinary differential equations, again, there's just one independent variable. So you can think of it like an x and a y. So the x would be the independent variable, and the y would be the function of x. So here would be derivative of y plus 5y squared equals sine y. That'll be an ordinary differential equation. And over here you have, say, x squared y double prime plus e to the x y prime squared equals ln of x y squared. That's also a ordinary differential equations. So pretty much the partial differential equation needs to have partial derivatives in it. So let's look at some examples of partial differential equations, so PDEs. Okay, so here's some examples of PDEs. Okay, so here's an example of a PDE. So we have a second partial derivative of z, derivative with respect to x and y, plus x squared y, partial derivative of z respect to x, plus xy cosine x z equals 1. This would be a partial differential equation because we have partial derivatives. And here we'd have two independent variables. So the x and y would be independent variables here. So we're assuming that z is a function of x and y here. Okay, all right, let's move on. So I'm going to erase some stuff here. So let me erase the stuff now, and then we'll move on. Okay, so next thing, the order of a differential equation is the order of the highest derivative in the differential equation. So let's look at an example now. So example, find the order of each differential equation. So say A, we have cosine xy times y double prime plus 17y prime plus y times x equals 1. So looking at this differential equation, it's an ordinary differential equation. Again, the order is the highest derivative in the differential equation. So here we have a second derivative here. Therefore, the order of this guy would be 2, so I'm going to write order equals 2 here. Alright, so order equals 2. Let's look at another example. So B. Okay, so B, we have x, y to the fifth, third derivative of y with respect to x, first derivative raised to the seventh, plus y to 12x plus 1. So let's find the order of this. So again, the order is the highest derivative in the differential equation. So be careful here. You might want to say that it's 7, but actually the first derivative is being raised to the 7th power. Or you might say, well, it's 12 because y is being raised to 12. But again, no. The order here would be 3 because that's the highest derivative the highest order of the derivative that you see in this equation. Because that's first derivative. There's no derivatives here. So 3 is the highest derivative in this equation. So the order for this guy would be 3. So again, order 3. Alright, so let's move on to the next thing. Okay, so next thing, an nth order ordinary differential equation that can be written in the form an x, this means a function of x, y to the nth derivative of y, so this parenthesis means, what the n in there means the nth derivative of n, nth derivative of y, sorry, the an minus 1, so some other function of x, times n minus 1 derivative of y all the way down, equal to g of x. This is called a linear ordinary differential equation. Okay, so let's look at some examples of linear ordinary differential equations. Okay, here's an example. So x squared plus 1 y double prime. So the x squared plus 1 is a function of x, so that's the coefficient. So basically the coefficient in front of the y derivatives needs to be a function of x. Excuse me, yeah, it needs to be a function of x, so the x squared plus 1 is a function of x times y double prime, and then the sine x squared, sorry, is a function of x times y prime plus 2 times y equals 9x. That would satisfy conditions of linear ordinary differential equation. Let me write another example that would not be linear. So here's another example here. It's almost identical to the one above, except I just took my y double prime and I squared it here. Because I squared it, it will now no longer be linear. So this would not be linear, this guy here. Let's look at one more example. Okay, so in this third example, we have xy plus 1 y prime. Well, you can see now this xy plus 1, that's not a function of x only, it has a y in there also. So therefore, that would not satisfy definition of linear differential equation, because these coefficients here have to be functions of x. Okay, so it's not a function of only x, so this would not be linear also. Alright, okay, let's keep going now. I'm going to erase some things. Let's keep going. Okay, a solution of a differential equation is a function. So let's look at an example of what I mean by this. For example, say we have y equals x squared plus 2x plus 1. This will imply then, if you took the derivative, y prime, so take the 2 down, it'll be 2x. This will be 2, derivative 1 will be 0. And say the second derivative would just be 2. So let's create a differential equation that has this as a solution now. So note now, let's look at y double prime plus xy prime minus 2y with plugging in our values here. So y double prime now is 2 plus x times y prime is this, minus 2y, so it'll be 2 times y up here. Okay, so working this out then, this would be then, let's bring it over here, so this would be 2, so it'll be plus 2x squared plus 2x minus 2x squared plus, minus 4x minus 2. Okay, so simplifying this, these will cancel here. The 2's will cancel. Just get then minus 2x. So hence we can say y equals x squared plus 2x plus 1 is a solution of the differential equation y double prime plus xy prime minus 2y equals minus 2x. So we made it that way. So therefore, our job then in general will be, if you're given some random differential equation, to try and figure out the solutions of that. So for example, if I gave you that and I didn't give you the answer, it might be difficult to come up with this as the answer. So in our class, we'll be learning how to solve these differential equations. Okay, so let's get going. So in general, it is not easy to find solutions of a given differential equation. So again, if you didn't know the answer to this differential equation up here, it'd be hard to come up with that as the answer by just looking at this. So in this class, we will develop methods for solving certain types of differential equations. Okay, so I'm going to leave it there in this video. We're going to pick up in part 2 in the next video.